Welcome everyone. My name is Nicholas Breckvold and I'm an AI engineer at Alice Exchange. It's a privilege to be responsible for this first entry into the Watch Me Build series, and I'm looking forward to taking you through building production-ready A2A agents on Google Cloud. I've been building and deploying software in Google Cloud for several years now, and it's an amazing ecosystem of incredible products and the perfect stage for leading into the world of agents and AI. That being said, the goal for this series over the next several weeks is to incrementally take you along the journey of building production grade agents from scratch on Google Cloud. This means going from first principles, explaining all the design and engineering choices along the way, and eventually getting to the point of hopefully having a very useful blueprint which you can leverage and adapt to your own agentic use cases and projects. So that being said, what is an agent? And Anthropic did a really good job in defining this. But in the very simplest of definitions, an agent is a combination of a large language model, i.e. some reasoning layer, and tools. The agent takes in some incoming request or task from a user or client, is able to use the LLM to reason about the task, and leverages the available tools to execute on and or make progress on that task. And finally, respond to the user with some generated output or response, and in some scenarios, even perhaps request for further input or information in order to continue that task. So that's a simple and useful mental model for thinking about what is an agent. Now, if you've been delving into the agent ecosystem lately, you probably would have come across agent-to-agent protocol or A2A protocol. This was originally released by Google earlier this year. This is not to be confused with the already popular Model Context Protocol, but in a nutshell, A2A is a completely open source project initiative since handed over to Linux Foundation and aims to standardize the way in which agents communicate and collaborate with one another in a multi-agent world. I emphasize agents since it's the clear separator in my mind between A2A and MCP. MCP is the protocol governing communication of an agent with tooling, i.e. intra-agent, where A2A relates to inter-agent communication, which is obviously quite different and distinct. Needless to say, these two protocols are quite complementary to one another, and we'll probably cover this later on in the series. But for today's session, being the very first session of the series, before getting stuck into any practical and hands dirty work in IDs and code, it's fitting that we have a solid understanding of what A2A is and the implications for building agents. So I'm going to keep today's session quite light and reference the official A2A project and supporting documentation, hopefully coming away with a better understanding of the key concepts around A2A, and then in the coming weeks get very practical and hands-on with starting to build out these agents. So just moving on to the homepage of the A2A project, there is quite a lot of content and resources here to help, which will not obviously cover everything today, but it's just worth pointing out that there's also a very active GitHub repository dedicated to the A2A project, so do check it out and follow the discussion threads, etc. Very useful information around what the A2A protocol is about. So in thinking about what A2A is and why, I find it quite useful to think and run a very simple thought experiment. So many people and organizations today are building and have built agents in the past. These are likely using some or other popular agentic sort of development framework or SDK, such as Google's very own Agent Development Kit, or LangGraph, or Crew AI, or perhaps even without any framework or SDKs at all. These are likely to being hosted or served on different platforms or cloud providers. And the problem with all of this is that there's no real clear way for these agents to communicate and or collaborate with one another. And while A2A does not dictate the tooling or framework you use to develop your agents or where you host your agents even, it cares about how these agents communicate with one another in a standardized way. So that's what A2A as a protocol is solving. So if you imagine your very own agent as existing in this black box with respect to the rest of the world, A2A is not concerned with how you choose to implement your agentic capabilities, but serves as a layer at the perimeter of your implementation as a form of API contract for how you promise to expose those capabilities and interactions with the outside world between humans and other agents. So if we just scroll down to the example scenario here, I think it's fair to say that many this is a very good example for highlighting like the need for A2A. I think it's fair to say that many people are adopting an approach these days of migrating to a world of specialist agents as opposed to generalists. This basically means that instead of having this one single generalist agent that can do everything for you, it's potentially a lot more effective, and one might actually expect better results if one has this set of specialist agents which have been handcrafted for very specific niche use cases. In this example, for flight booking, for hotel reservations, etc. And naturally, if this is the case and the path that's being moved towards, the need to solve agent communication in a reliable way is actually a requirement and totally relevant. And so I hope then you can appreciate why A2A is a big deal towards this vision. And I'd argue that anyone building agents should have a good understanding and familiarity with the A2A protocol. So moving on just to the core concepts, this is a really nice illustration again of the A2A protocol and who all the sort of actors and participants are in this agent world. If you consider the sort of the user and the client and all these client agents, so the user's obviously got initiating some request or goal to be achieved through leveraging agents. They have this client agents through which they are speaking to or sending these requests to. But again, this client agent of that the user is using is not necessarily the specialist for the particular task or request that the user may have, and so it relies on engaging with these other agents in order to fulfill that request or to answer the user's question, get back to the client agent, and then surface those results to the end user. And so the main core actors in this A2A ecosystem are, of course, the user and the A2A client, which is just a sort of application service that acts on behalf of the user, and then these remote agents. And this is all made possible if the A2A client and A2A server are all speaking the same language, i.e. the A2A protocol, in the way that they communicate back and forth with one another. So there's a couple of fundamental communication elements that are key to understanding the A2A protocol, and I definitely invite you to read this in detail. But just to highlight them briefly now, you've got the agent card. So the agent card, you can think of it like your business card for an agent. So it describes effectively advertising the capabilities and skills that the particular agent has and the supported mechanisms through which one can engage with that agent, which we'll get to in a moment now with the interaction mechanisms. Just think about it as your agent card, who you are, what you can do, and how you can interact with them. The next really relevant thing concept is this concept of a task. So a task is basically a very well-defined unit of work performed by an agent. So this can be something as simple or as complex as required. For example, something as simple as a Q&A style engagement can be modeled as a very short-lived task. But equally useful as a task could be something like planning or booking an entire holiday trip, right? Where the task progresses through multiple states or phases of completeness throughout that life cycle. And so both of those cases one could represent as a task. Messages, on the other hand, are more aligned to sort of just very simple point-to-point communication. So messages are stateless, whereas tasks have a progress of states that they can go through. For example, the task has been submitted, the task is busy being worked on, input is required on the task for human-in-the-loop workflows, whereas messages are just a pure point-to-point communication. So both messages and tasks do are comprised of sets of parts, and a part you might be familiar from using some of the Gen AI SDKs of Google, like with Gemini. There's often at the concept of this part, and a part is effectively just a fundamental container for shipping a piece of information to a model in the case of a Gen AI SDK, and to an agent in the case of A2A. So, for example, if you need to ship some text, that is one type of part. If it's some file contents, that's another part, and some sort of JSON data, that's the third part that's supported by the protocol. And these messages and sort of task updates and sort of different states, etc., that the tasks can go through, they're all communicated via this sort of central little piece of fundamental container referred to as a part. And that provides all the flexibility for how and what can be conveyed over the protocol. And then finally, there's artifacts. Artifacts can be thought of as the generated output or results of a task. For example, if you imagine you'd ask an agent to generate an image or a video, that would be a very good candidate for what an artifact is. That as part of the task, asking you question, please generate me a video of X. The agent would create a task for this, and once the task has been completed by the agent, an artifact would have been produced which would contain the generated image or generated video, whatever would be the case. Now, moving on to some interaction mechanisms. So the A2A protocol supports three main interaction mechanisms with different levels of complexity or expectations from the client side of how to deal with these. The first is just very simple polling. So imagine just a simple long-running operation request being made to a client, please do X for me, and I'm going to give you back a task immediately, and your role is to just keep polling that the state of that task, and once it reaches some completed state or failed state, for example, you as the client will then know how to respond or react to that task. You can get that task and view what the current state of it is at any given point in time. Now, in some scenarios, polling is not always the most efficient or effective way to do this. And in order to receive results immediately as they are available in real time, A2A also supports a streaming mode in order for your agents to communicate one another. And so that means instead of having this sort of request response with polling, the client sends a streaming request to the remote agent, and in that doing so creates a stream link between the two, stream connection between the two, and the agent will then asynchronously send the client events as and when they are available, and the client can then receive those events and update their sort of database or state around that particular task accordingly. Now, even this has its limitations because for very long running tasks, it's not always efficient to, number one, poll for tens of minutes or even hours in the first case, or maintain a reliable live stream connection for, again, tens of minutes or hours. So the third sort of mechanism that's supported by A2A is this push notifications. So push notifications, the client, when engaging with the agent, sends the task or sends a message, this is the request I need from you, and this is a push notification config that I'm giving you alongside this request. And the expectation is that the agent, as it works on this particular task, it will then push notifications to the provided endpoint in that configuration in a webhook style. And so the client can listen on that webhook and receive events from the agent in that way. And that, if you imagine, that does not require the client to maintain any particular connection with the agent. The agent is free to go on and work on a particular task, taking however long is required, and just maintaining updates to the client as and when is necessary. And eventually, once the task has been completed, the client will get that final sort of update push notification, and then the client knows that the work has been done. Just a little bit on agent discovery. I did mention the agent card, and this is very important in terms of discovery and these multi-agent systems, how they are able to actually collaborate with one another. So the agent card being the business card, just a reminder again, the business card of these different agents. If you have these client agents looking to do a task or looking to perform a task, and they need to know, who do I delegate this task to, the agent card is effectively the discovery process for that to happen. And so so agent card, very important sort of concept, and defined by the A2A agent, and that's typically hosted at some well-known URL on the agent server, so that it's sort of a predictable place for clients, or agent clients or remote A2A servers, to be able to find that information in order to know whether they need to engage with an agent or not. And then just quickly, just before closing out today's session, in terms of enterprise readiness of the A2A, so A2A has not reinvented the wheel in terms of security and authentication and best practice around that. Instead, that has all been delegated to well-established security mechanisms such as OAuth, etc. So there's no security or authentication authorization mechanisms specified directly into the protocol itself. It relies on standard and well-accepted best practices. So that is sort of out of band and out of scope of the A2A protocol, although a very, very important aspect to agents communicating with one another. One always has to assume that any actors trying to engage with a particular agent are obviously bad actors, and therefore one should always make sure that any users or clients to your particular agents have the correct credentials and authentication and authorization requirements to engage with that agent. Lot of sort of talk in the ecosystem about this specifically difficult challenge to solve. But yeah, we'll hopefully cover this in one of the videos in the coming weeks, as we sort of flesh out these patterns a bit more. Just one last thing to maybe say about the A2A protocol. There is really a growing popularity and adoption of A2A in the agent space, as highlighted by the sort of growing list of partners actively contributing to and developing the A2A spec. I think there's a strong signal that the ecosystem and industry out there realizes the challenges that these multi-agent systems present and the unlockable value by solving these challenges. And so I'm personally very excited about this and look forward to getting hands-on and practical in the code side of things next week. And yeah, look forward to it. Until then, take care, and yeah, appreciate the time, and thank you for watching.